Right, ladies. So, I never went over exercise 5 with my class, so I'm just going to try explain some stuff quickly by going through a few examples from exercise 5 of your geometry books, Mind Action Series. We're on page 40. Up to this point, you'd always been asked to prove triangles similar. They told you, like, prove triangle ABC similar to triangle DEF, but now you're going to have to find the triangles which you need to prove similar in order to prove a ratio. Ratios are equal. So in this question, you're asked to prove that AE of C is equal to AD of BC. Well, first of all, you couldn't use the proportionality theorem because there are no parallel lines here. So similarity, then, in this case, is going to be our only option. So the trick is to find which triangles you're working with. Well, first of all, don't need to just look which triangles look like they could be similar. Well, the big green one and then this little EBC look like they've got the same shape, so that's an option. In fact, it's our only option in this case. But just to check, if you look at the sides, well, there's AE over there, and there's AD is also a side of that triangle, so they're both part of the green triangle. And then if you look in this triangle over here, CE is a part of this triangle, and BC is a part of this triangle, so there's another triangle over there. So we've got the green triangle and the yellow triangle, which we are going to try to prove are similar to each other. So I like to use color in this section. So in triangle, let's look at the green one, AED, let's say, and triangle. Just tell us which triangles you're working with, and just go straight into it. And triangle BEC. Okay, so I've got the green one, AED, and the yellow one, BEC. Okay, now I need to find three angles which are equal to each other. Okay, well, this is a cyclic quad, so you can see that B2 over here, the exterior angle of the cyclic quad, is equal to the interior opposite angle. Okay, so we're going to have B2 is equal to D. Okay, so D is in the green, keep the greens underneath each other. So I've got D in the green equal to B2 in the yellow. Reason, exterior angle of cyclic quad. Okay, so I've got D in the green equal to B2 in the yellow. And then I've got C2 is an exterior angle is equal to the interior opposite angle. So A in the green triangle is equal to C2, oh, that's about, A in the green triangle is equal to C2 in the yellow triangle. Same reason, exterior angle of a cyclic quad. And then I've still got E in the green triangle, well, is equal to E in the yellow triangle. Obviously, those are common angles. Okay, so I've got three angles. Now when you write it up, write it down in the correct order. Okay, so like that. So in that order, because then you can just use the little kind of username to prove proportionality. So we've got triangle DAE in the right order is similar to triangle BCE. That's now in the right order. Okay, and reason, angle, 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 where you can write equiangular. Right. So because they're similar, the sides are in proportion. So I would just write down all the sides in proportion. So I'm going to have, here's the green, here's the yellow. So I'm going to have DA in the green. What goes with it? Well, it's in the right order, so I can use this technique instead of looking at the diagram. So DA over BC in the yellow must be equal to DE in the green, first and the last, over BE in the yellow, which must be equal to the two last ones, AE in the green, the last one here is CE. Okay, and so I've got the greens all over the yellows. Okay, and the reason is, well, the reason is because those triangles are similar. And if triangles are similar, sides, corresponding sides, must be in proportion. So that's your reason why we can make that statement. then just look at the question. We've got AE over CE, so we need that, and we've got AD over BC, which is that, so we don't need that one, so we can cross that out, and we are done. Right, I'm now going to do question 3 on page 41. Okay, this question, first of all, make sure you fill in everything on your diagram. So the question says PT is a tangent, so just fill that in always to remind yourself what you're given, blah blah blah, and you're given some other stuff. Prove that BT over BP. Well, when I did this question, again, hang on, let's just have a look. You've got 3 triangles here, that yellow one, that green one, and this one over here. But if you look, okay, this one over here, if I use triangle BTP, that's obtuse, okay, and the only other obtuse angle triangle really is this triangle, the green one over here. So I must be working with the green and the yellow. Those are the only ones that look similar. In addition, if you check over here from your diagram, if you go, okay, I've got BT, that's the one side, I've got BP, that's 2 sides of the triangle, so I can make the 3rd side of the yellow triangle, and then I've got AT, okay, and I've got PT, so the green triangle can be the 3rd side of that triangle. So if we can prove those 2 triangles, the green one and the yellow one, similar to each other, then we should be able to prove this ratio over here. So I'm going to say, right, so first of all, mention what triangles you're working with. So in the yellow triangle, doesn't matter the order we write it in now, at the end it's important though, in triangle BTP, the yellow one, and the green one, and triangle APT. So APT is the green one, BTP is the yellow one. What do I have? Well, first of all, this is a tangent, right? Okay, so this angle over here, the angle between a tan and a chord, must be equal to angle in the alternate segment. Okay, so T2 in the green must be equal to B in the yellow, right? T2 is equal to B. So in the yellow, we've got B is equal to T2 in the green. So B in the yellow is equal to T2 in the green. What's the reason for that? Tan chord theorem. Okay. What else have I got? Always look for that common angle, guys. P is a part of the green triangle and it's a part of the yellow triangle. So P in the yellow is equal to P in the green, okay? Obviously, reason, common angle. And remember now, if you've got 2 angles, okay, the third is automatically equal because angles of a triangle add up to 180 degrees. So what haven't we used in the yellow triangle? Well, we've used B and we've used P, so we've still got this big angle over here, the obtuse angle. So the obtuse angle here, which we can just call angle T1 plus T2 in the yellow, must be equal to, and I haven't used the obtuse angle here in the green, which is A1. Okay, and the reason for that is it's because third angles of triangle. Right, so I've got yellow and green there. Now remember, write it up in the correct order, so we can just use the names to get the similarity, to get the sides which are in proportion. If you don't get in the right order, you can't use that technique. So therefore, triangle BPT, written in the right order, is similar to triangle TPA, angle, or equiangular, doesn't matter. Okay. Now because they're similar, we can write up the corresponding sides are in proportion. So I'm not even going to look at the question yet. I'm just going to say BP in the yellow over first 2 over TP in the green, first 2 there, must be equal to first and the last in the yellow, which is BT, over first and the last in the green, which is TA, which must be equal to the last 2, which is PT, okay, over the last 2 here, which is PA. So this was BPT, and that was BT over there. Okay, PT over PA. Okay, I've got that right. PT is the last two, PA is the last two. So those are all the sides from the yellow. And there's all the sides from the green. And the PT is a common side, so it occurs in both triangles. There's PT, it's part of both triangles. And the reason for this is because the triangles were similar. So triangle BPT, in the right order please. BPT is similar to triangle TPA. That's your reason. Okay, now which ones did I want? Well, I've got BT and BP. Well, BT and BP involve those two things over here, and then I've got AT and PT in the green, which involves those two things. So I can pretty much rule out that ratio over here, and then I'm going to just manipulate these. Well, I want to end up with just a bit of algebra really. So if we could do the denominators, various ways you can do this. You'd have BP times TA is equal to BT times TP. Okay, just multiplied by the LCD, but I want to end up with BT at the top. What do I end up with? Yeah. So I want to end up with BT over BP. So if I divide out both sides by BP, I get, as I say, you can skip out steps here and there are all kinds of ways you can do it. If you divide both sides by BP, you get BT times TP over BP. Okay. And then I want to have, so keep looking at the question, I've got AT at the top and now I need PT at the bottom, so if I divide by PT, divide by that one, I get AT, I've just reused in the order, over TP is equal to BT over BP. Quite honestly, if you've got the right ratios and then you just went straight to that, you get all the marks, because it must work out in the end, but there's some kind of explanation for you. Hope that makes sense. Right, let's have a look at question 5 on page 42. So first of all, let's just make sure you've got the cyclic quad. We might need it, we might not. Okay, ABCD is a cyclic quad. I don't know if we're going to need that or not. Let's have a look. And they tell you that these lines are parallel, so don't forget to use that somewhere. Okay, that line is parallel to that line. Just make sure everything's on your diagram. And the question says you've got a ratio. Okay, AP and PC. Well, there's no triangle. I can't use the proportionality theorem, so I must be using similarity. So the trick now is to figure out which triangles we're going to be working with. Well, we've got AP, which is over here, and then I've got PC, which is over here. I mean, they can't be part of the same triangle. And then I've got, so PC is the green one over there. Then I've got PE, which looks like it's going to be the same part as the yellow one. So there we go, the yellow one there. And then that must be our one triangle that we're working with. Okay, triangle APE. And then I've also got, just to check, PD. Okay, which is over there. So I'm actually working in the yellow and the green triangle, and you can see they've roughly got the same shape. They could be similar. Or let's just check that intuitively it makes sense. So tell the marker which triangle you're working with. So in triangle, the yellow one is APE. The order of the letters doesn't matter here. And triangle, whatever, DPC. So I've got the yellow one, and I've got the green one. So in triangle APE, well, what have I got angles? Which angles are equal to each other? So I've got P1 in the yellow must be equal to P3 in the green. What is your reason? Vertically opposite angles. Maxine, put your phone away. P1 is equal to P3, alright. And then, well, they gave us, we've got a parallel line, right? So if I look over here, A2 in the yellow must be equal to C2 in the green. Okay, because you've got these parallel lines over here. So there we go, there's my Z shape. Okay, between parallel lines. So A2, here's my yellow, here's my green. So A2 in the yellow must be equal to C2 in the green. Okay, and the reason is, what have I got? Remember, the reason is always what you got, not where you're going. Alternate angles, and you've got AE parallel to DC. Right, and then the last one I've got is, well, you can just use leftover angles in the triangle, or you could use alternate angles, whichever one you want. Okay, so I'm going to say E1 in the yellow must be equal to D2. E1 in the yellow must be equal to D2 in the green. Okay, what's the reason for that? Well, you could use alternate angles again, because you've got your Z shape, or you could use third angle of a triangle. Let's just use alternate angles, it's easier. Okay. Now we write it out in the correct order, so therefore triangle, go down, PAE is similar, go down to triangle PCD. Okay, what's the reason for that? Or either equiangular or angle, angle, angle. Okay, now I write out the ratios. I can use this technique because I've written them in the right order. So PA in the yellow, those are the first two, over PC in the green, must be equal to the first and the last, which is PE in the yellow. First and the last here is PD, which must be equal to the last two, which is AE in the yellow, over the last two, which is CD in the green. Okay. Right, and the reason for that is because triangle, what was that? Triangle APE is similar to triangle DPC. Okay, then just look at the question. Well, we've got AP and PC, which is over here, so we're going to use that, and we've got PE and PD over there. Okay, so we've done, you can cross that out a bit, and we've asked, okay, we've proved what we set out to do, so there is your answer for part A. Right, now 5B is quite a common type of question. Okay, so you need to watch out for it. So the question says, I'm writing up here now, okay, so we can see the diagram. Okay, just make sure this is focused. Right, so here's part B. Up here, I'm just going above here, it's still question 5. So the question says, prove that AP squared is equal to BP times PE. Now, in this situation, always rewrite it as AP times AP is equal to BP times PE. So what that's reminding me of is we need two triangles with AP as a common side. Okay, so AP is a crucial side here. Then let's have a look at the other sides. What have we got? Well, we've got BP. Okay, and BP is over here, so we could be working to, I've got to have AP as a side, and then I've got to have BP as a side. So to do that, I must be working in that purple triangle. So in the purple triangle, okay, I've got triangle APB, but then in this pink, shocking pink one, I've got AP again, which is this side over here, sorry, it's all becoming a bit of a mess, and I've got PE, which is this. So here I'm going to use that triangle over there. So I'm going to have this big purple triangle on the outside and the pink one over here. So I'm going to say, so be careful of that squared. It means AP must be a common side. AP is common to that triangle and AP is common to this triangle over here. So tell what triangles we're working in. We're going to say in triangle, this is P, don't forget. In triangle APE, the pink one, which is kind of looks like some weird color now. In triangle APE, okay, which was the yellow one in the previous question, but we'll stick to pink now. And triangle, the purple one on the outside is triangle APB. So I've got the pink one, APE, and I've got the purple one, APB. Okay, right. What angles do we have? Well, first of all, I've got P1 is common to both. So P1 in the pink is equal to P1 in the purple. Okay, reason, common. Okay, right. Then what else do we have? P1 in the pink equals P1 in the purple. Can I use our parallel lines? Not really. I'm going to have... Right, so then I'm a little bit stuck. So there's no direct obvious thing. Okay, so we've got P1 is common between this pink and the purple one, and then there's nothing that's direct. But if I have a look, B1 in the purple, okay, I'll go back from here to AD. AD also subtends C2 on the circumference. So I'll go there and now there. So B1, okay, must be equal to C2. So I've got B1 in the purple must be equal to C2. Reason, angles in same segment. I used, you don't have to write this, but I used AD. Just helps your marker to see what you're doing. So AD subtends both of those. So B1, the two lines here, must be equal to the two lines here. But in the previous question, okay, well, you don't even need the previous question, you've got alternate angles, right? Okay, so we've got B1 is equal to C2, and we've got C2 is equal to A2, alternate angles, or you can say proved, alternate angles AE parallel to DC. Okay, so they're both equal to C2, so they must be equal to each other, so therefore B1, okay, in the purple triangle is equal to A2 in the pink triangle. Let's keep it in order. So A2 in the pink triangle must be equal to B1 in the purple triangle. There's no reason for that, it's just logic. So A2 in the pink is equal to B1 in the purple. So we've got 2. Okay, so the third one, you just need to find the third angle in each triangle must be equal. Well, in the pink we've used P1, we've used A2, so what's left over? E1 is left over in the pink. So E1 in the pink must be equal to, what's the left over in the purple? We've used B1 and we've used P1. So in the purple it's A1 plus A2. So E1 in the pink must be equal to A1 plus A2 in the purple. Okay, and what's my reason for that? It's the third angle of the triangles. Okay, so therefore, if I write it down in the correct order, in the pink, triangle PAE is similar to, in the correct order in the purple, triangle PBA. What's my reason for that? Angle, angle, angle. Okay. Sorry to be a pain, but I'm going to go up here. And let's just go across here. Can you see across here? You can. Okay, so I'm going across to here. Okay, to carry on with question 5. So I've got those. I've shown, okay, that the pink triangle is similar to the purple triangle. Okay, we're in, sorry about this, in this diagram over here. The purple is equal to the pink. Okay, now remember, so let's write down what ratios we've got. So we're going to say PA is the first two over here, so PA in the pink, okay, over the first two here, which is PB in the purple, the first and the last in the pink, okay, so PE in the pink, over the first and the last in the purple, which is PA, must be equal to the last two in the pink, which are AE, and the last two in the purple, which is BA. Okay, so I've got all the pink ones at the top, all the purple ones at the bottom. Okay, why are those ratios equal? Because triangle PAE is similar to triangle PBA. Okay, Now, we're looking to go show, if you look way back here, that AP times AP. So I need AP there, there's AP and there's AP there. That's going to give us our PA squared. And then hopefully I've got PE, yep, and I've got BP or PB, same thing. So this one's not going to be relevant. So if I times out by the denominator, I get PA times PA is equal to PE times PB or BP, same thing. So therefore, PA squared is equal to PE times BP, and we are done. Right, so that is 1, 3, and 5. The numbers for the rest of your exercise have been sent to you. I hope that all makes sense, and good luck.